Hello, welcome to ANS Solver. This is the seventh question of the paper. As you can see, x and y satisfy this differential equation. We know that when x is 0, our y is also 0. So let's get into the sum. We need to solve the differential equation and show that y in terms of x. So now the first step is to keep this in the variable separable form, which basically means keeping all the y's together and keeping all the x's together. So basically, if you see, my tension comes here, e raised to x plus y. How do I write this in the correct form? You need to know a simple indices formula for this. You know that a raised to b plus c can be written as a raised to b into a raised to c. Correct? This is what I can write. So using this indices formula, I can write this as dy by dx is equal to x into e raised to x into e raised to y. Correct? So now I can write this as 1 over e raised to y dy equals to x into e raised to x dx. Correct? So I have written in the variable separable form. So now I can write this as e raised to minus y dy equals to x into e raised to x dx. Okay, so now I basically integrate both sides and I make a partition here between them. Okay, so now e raised to y integration. It's simple, it's the same, e raised to minus y as it is over the coefficient of y, which is minus 1. Now, the integration of x into e raised to x dx. For this, you need to recall your further integration chapter where we studied about something called as bypaths. So, this suggests something called as I-late, if you remember, where I basically means inverse, okay, L means logs, A means algebra, T means trigo, E means exponents. Yeah. So now if you see, x is basically my algebra, E is basically my exponents. Correct? So whichever comes first gets U. So algebra comes in I-late first. So U is x. And whichever comes after or the last in I-late, which is E here, so that gets V dash. So now I'll calculate my u dash, which is basically the differentiation of x, which is 1. And now I calculate v, which is basically the integration of e raised to x, which is the same as e raised to x. So now I have my formula, which is uv minus the integration of v u dash. So u into v is simply x into e raised to x. Okay, there are no limits obviously as it's indefinite integration. And now I have the integration of vu dash, which is e raised to x into 1. So I have e raised to x. So now I can write this as x into e raised to x minus e raised to x plus c, as there are no limits. So now writing everything together, I can write this as minus e raised to minus y equals to x e raised to x minus e raised to x plus c. So now what I need to do is I need to calculate my c. Obviously I need to calculate my c because I need to write y in terms of x, correct? So I know my x is 0 and I know my y is also 0. So now just substitute in the equation e raised to minus 0 equals to 0 into e raised to 0 minus e raised to 0 plus c. So this is basically, this gives me minus 1 equals to 0 minus 1 plus c. So this gives my c basically as 0. Correct? Easy to solve. Now I have my equation basically as minus e raised to minus y equals to, I can say this is basically x e raised to x minus e raised to x, and because the c is 0 we don't need to write it. Now what I can do is I can write this as minus e raised to minus y equals to, I can take e raised to x common to get x minus 1 here. Correct? So now I can write this as e raised to minus y equals to minus e raised to x into x minus 1, which can be written as basically e raised to minus y equals to e raised to x. I can take the minus inside to get positive 1 minus x. Got it? This is what I can write. So now what I can simply do is I can ln both sides. Ln e raised to minus y equals to ln e raised to x into 1 minus x. Correct? So now what I can do is I can use two properties. The first log property which I can simply use is simply, I can say this is log a raised to b can be written as b log a. This is the property I can use first. Then other property which I can use is simply log of a into b can be written as log a plus log b. So using these both properties, what I can do is I can basically write this as minus y into ln e equals to ln e raised to x plus ln 1 minus x. So I can simply write this as minus y equals to, I can use this property here, so I can write this as x. I know ln e is 1, so I don't need to write it, plus ln 1 minus x. So now I can write this as y equals to minus ln 1 minus x, which is basically I took the minus to the other side, which is the answer of the question. Okay? Now, explain why x can only take values less than 1. If you notice here, so one important property you need to know is that log of negative is not possible. Okay, is not possible. So if I take a value of x here, okay, which is less than or which is more than, let's say, 1, I'll get my log of negative. So I can simply state that the log of a negative value is not possible, hence x needs to be lesser than 1. Because if it exceeds 1 here, I'll get a negative log, which is not possible. So yeah, that's why.